Hey everyone, I'm Sangeeta Lakshmi, working as Assistant Professor in EC department in R.M.K College of Engineering and Technology. Today we are going to see the Unit 1. We are going to see the layout and stick diagram. I have taken the question that draw a stick diagram of Boolean expression y equal to a plus b into c the whole bar. Okay, so in this I will take the Boolean expression, right? So I will tell you the small trick. That is, if you have the multiplication, you have to use the parallel combination of p marks. Okay. If you have the addition, you have to use the series combination of p marks. So first of all, you have to remember these two because before they are going to draw the layout and stick diagram, you have to know how to design if any expression is they have given. Okay. So here a plus b. So a plus b means it is addition. So you have to use the plus means series, right? So how many variables are there? First of all, you have to know a plus b into c, three variables. So here you have three variables means totally we need three p marks and three n marks. So total transistor is 6 transistor. So here I will draw how to design this a plus b. I told you it is multiplication, sorry, addition. So you have to use the series combination. Okay. So series combination means it is p mask, another transistor. So here the input for the first one is a, second is b. And these two a plus b is multiplied with c. So multiplication I have to use a parallel combination. The input here is c. Okay, so this is nothing but the pull up network which consists of PMOS. The bubble indicates that it is PMOS. It is connected to the supply VDD. And we have to form the pull down network which consists of NMOS. Always the connection is opposite to the pull up network. Here A and B are series. So I have to use a parallel combination of A and B. Okay. Then C is parallel with A and B in the pull-up network. Here we have to use a series combination. So here it is connected to ground terminal. The output is always taken between the pull-up and pull-down network. So first thing is if you want to draw the layout or stick diagram, you have to mark the terminals because the transistor having the gate, source and drain. So first of all, we have to mark the terminals. I will change the color. Here you can see it is always the output should be, the output is we have taken at the drain terminal. Okay. So it is drain. So here also drain, here also drain, this is also drain. And if it is drain means this another terminal is source. It is series no, so always opposite terminal we have to place. Here it is source. And here it is drain means obviously it is source. Here it is drain means for this transistor also it is source, it is source. It is series connection, so opposite terminal drain. Here it is source. Okay, so I have marked all the terminals. Okay, so next I have to use the transistor. I have to give the name. It is the P1 transistor. It is P2 transistor. It is P3. Similarly, for NMOS transistor, I will give the name N1. It is N2. It is N3. Okay, three transistors for this pull down and three transistors for this pull up network. So next I will draw the layout and stick diagram. So for that also you have to remember for the P mask always you have to use the yellow color. Okay, for N mask you have to use the green color. If you want to draw the layout you have to remember these all the colors. For the polysilicon, polysilicon means it is nothing but the gate terminal. Gate is formed by polysilicon. You have to use red color. Where we have the gate is, wherever you are giving the inputs, these all called as gate terminal. Okay, so these all called as gate terminal. So polysilicon, then we have to use the contact. If you want to make the connection between 2 points, you have to use the contact. So for the contact, you have to use the cross symbol with the black color. And if you want to make the connection between the 2 points, you have to use the wires, or it is called metals, right? So for metal, you have to use the blue color. So these all the colors you have to remember before drawing the layout and stick diagram. So first, in the upper network is full up network, which consists of PMOS. So for PMOS means we have to use the yellow color. I will take the yellow color here. So first I have to draw the yellow color. Then I have to use the NMOS, that is transistor, which is green color. Then how many transistor in pull up means it is 3 transistor. Similarly, pull down also 3 transistor, right? So we have to use the polysilicon by using red color. Here I am placing one transistor. Actually, this is one transistor. This is another transistor. This will be third transistor. Okay. Similarly, pull down also 3 transistors. So 1, 2, and 3. Here you can see the P1 transistor input is A and N1 transistor input also A. Right? So we can connect both together. This is the P1 transistor. This is the N1 transistor. The input for both is A. Similarly, this is P2 transistor. It is P3 transistor. It is N2. It is N3. Okay. P2 and N2. See here, the P2 input is B and N2 input also B. So both will be connected together. Instead of giving separate inputs, we are giving same input to both the transistors. And P3 also the input is C here, and for N3 also the input is C. So I will connect both the transistors together and the input is C. Okay, then I have to give the connections. First I have to place the terminals in the layout diagram. Layout is nothing but a physical diagram. In IC you have this kind of structure only. So here what is the relationship between P1 and P2? First of all we have to know. Here P1 and P2. P1 drain is connected to P2 source. So P1 drain is connected to P2 source. So I have marked here. Similarly, what is the relationship between P3 and P2? P2 drain is connected to P3 drain. So here it is obviously, it is source means it is drain. So P2 drain is connected to P3 drain. So I have marked the drain here. It is drain means obviously it is source. Here it is drain means it is obviously it is source. Okay. Always the input is given at the gate terminal. These all gate terminals. Okay. So similarly for the pull down network also we have to mark the source and drain terminal. What is the relationship between the drain N1 and N2 is, for N1 transistor drain is connected to N2 transistor. So I will take here N1 drain and here N2 drain. So it is drain means it is source, similarly it is source. Now N2 and N3 relationship you can see, N2 source is connected to N3 drain. So I will take here drain. So it is drain means obviously it is. Like that only we have to choose the terminals first. Okay. Then we have to make the connections one by one. So for the connection first we have to place the contact. For that I will take the black color. Where we have to place the contact means, see here, P1 source is connected to supply VDD and P3 source also connected to supply VDD. So I will mark, that is place the contact over the P1 source and P3 source. Both will be connected to supply VDD. Okay. For that we have to use the metal color. So I will take the blue color. So here we have supply VDD. Okay, so this portion is over. Here P1 source and P3 source is connected to VD. This portion is over. Next, P1 drain and P2 source also we have marked, right? That is over. And then P3 drain and P2 drain we have to connect together, right? That is also we have chosen here. Next, so pulled up is over. And pull down network, drain of N1 and drain of N2 should be connected to drain of P2 transistor and drain of P3 transistor. So here we have the P2, we have to take the black color, P2, P3 drain should be connected to N1, N2 drain. That means this portion, right? So here I have marked the contact over here. Next I have to use the metal, that is blue color, for making connection. So this is my output bulb. Okay, then you can see the source of N1, source of N2 must be connected to N3 drain. Okay, so we have take the again contact. N1 source is connected to N2 source as well as N3 drain, right? That means this point we have to make the connection. So I will take this source, here also source. So this point is over. So by using blue color only, we have to use this connection. Okay. Then the source of N3 is connected to ground terminal. So I have to place the contact over there. Wherever if you want to make the connection, first we have to place the contact, then you have to use a metal wire. So here I will take the metal for giving the ground connection. So this is the layout of A plus B into C. Okay, it's a very simple concept only. You can try it. If you want to draw the layout, the same diagram, without using rectangular shape, just you can use a single stick. It will become the stick diagram. Okay. So first I will start with the yellow color. Now I am going to draw the stick diagram. So first I will take the yellow color. Then I have to use the green color for the N mask. Then I have to use the polysilicon over that. So 3, right? This is A, this is B, this is C. Then I have to use the contacts. See the layout, you can easily draw the stick diagram. Here I have to place, and here also I have to place, here also I have to place. Similarly here, because we have 4 place contacts in the downside and 3 place in the upper side. Then I have to use the blue color for making connection. See here from the supply, this is VDD, and here it is connected to ground, and then from here to here this connection, and then output where we have to take this is the output. It must be connected here. That's all. This is the stick diagram. So this is stick diagram. This is your layout diagram. So first step 1 is You have to draw the design and then mark all the terminals, give the name of transistor P1, P2, N1 like that. Then you have to start with the layout diagram. For the layout PMOS, you have to use yellow color. For NMOS, it is green color. And you have to place the polysilicon by using red color. Then you have to place contacts by using black color wherever. If you want to make the connections, that you have to place the contact. Then after placing the contact, you can use the blue color for forming the connection. Okay, so this is the layout diagram. In layout, we are using the rectangular shape, but stick diagram, you are using single wire, that is single line of diagram you are using. That is the only difference. Okay, I hope everyone is clear about the layout and stick diagram. With this, I wind up the session.